Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook. Welcome to EV Components Review. This is the logic board for a Talaria controller, and here is its power stage. So obviously this is all your DC filter caps for keeping the battery bus in here clean and nice and smooth. Yeah, and this is the exact same capacitors, model, part number, values, everything is what's in the Surron controller. It's almost like these were both made in the same factory or something, by slightly different people. You know, the coincidence factor that all the capacitors are identical is really kind of surprising. This is your I/O connector, and this used to plug in there. Of course, it was all potted and I had to dig it out, so I just cut off the cable and dug it out later. You have 3 current sensors rather than 2 like the Surron has. Definitely like 3 current sensors more than I do 2, because that way there's no assumptions what each one of the phases are doing. You simply know, because you get sensitive data, you know, current measurements off of each one of the phases, and that's good. Right here and here and here are the 3 Hall sensors, or I'm sorry, the 3 gate drivers for the MOSFETs, and they have MOSFETs, small MOSFETs, right next to them. And so I'm thinking that maybe these gate drivers might not be powerful enough to run these MOSFETs by themselves. And so maybe they need these smaller MOSFETs to like up the current to drive these, because they're next to each one. So there's that MOSFET, you know, there's that gate driver right there, and it's got a MOSFET here and here, and then like this one here, it's got a MOSFET there and there. So yeah, it definitely seems to be that's the case, but I'd have to look up this part and see what its current rating is, and look up these MOSFETs to see what their gate drive current is, and then I would know. Anyway, right here is your CPU. Considering its physical size, there's a fairly good chance that this is only sinusoidal control and not field-oriented control, like I believe that the Surron controller is. It's actually got FOC in its part number, and this does not. So probably this is just sinusoidal. Right here is your main DC to DC for converting battery pack voltage down to 12 volts. And then like the Surron, this is a dual voltage board, and that's a 5-volt regulator for pretty much everything else. So 12 volts is probably powering like the 3 gate drivers, and then 5 volts is powering everything else, including the CPU. Alright, let's flip it over. Don't much care for this. Yeah, I don't ever like it when the logic board is used as a power stage, or is used as a current path. And here it is again. So, you know, KO Moto does it, Surron does it, and here it is on the Talaria controller too. So, yeah, this all through here, this is all battery minus, and you can see the vias. So there is another circuit trace on the top of the board that kind of mirrors this one. And then across here is this much skinnier battery plus, but again, it's got vias that go up to a piece of copper that's right up here at the top. It's not a great plan of attack to do things that way. I really don't like seeing this kind of thing where you've got your logic board as a current path. This is, you know, it's kind of cheating in my opinion. Really what you should have is a lot of copper down on your power stage instead, because that's where you need the current. You don't need it up here. You just need to clean up the battery bus, and that's about it. And, well, yeah, this is an important piece, especially this battery plus part. That's an important piece of powering this controller. So let's look at the power stage and talk about that for a minute. Alright, so this is a little better than like the KO controllers. So there's copper underneath here, and it's about 15 or 16 millimeters wide, whereas like on the KO controllers, this is only 8 millimeters wide, and of course it's the same thickness of copper. So here's battery plus, and you got a stud here, and a stud here, and a stud here. So that all goes to those 3 studs. But yeah, you've got twice as much width of copper here. That's all underneath those MOSFETs for battery plus. So that's somewhat better than, like, say, KO does it, because theirs is obviously much thinner, you know, much narrower. It's only about 8 millimeters wide, and I know for a fact that that one burns through. I've seen it. Yeah, this is lower wattage, but you know, there's a lot more copper here, so it's probably enough-ish for this power stage, you know, considering its wattage. But still, you know, all you have to do is shift all these MOSFETs down a little bit, and then you could take a piece of copper and run it from here all the way across the top here, and, you know, reinforce all that stuff. So you had a nice piece of current path across here, in which case this doesn't need to be a supplemental current path at all. This is just ripple filtering. So yeah, not super fond of that. Battery minus is a skosh better. So here's your battery minus post, and you can see it's reinforced with solder, which is, yeah, it's better than nothing, I suppose, but still not awesome. Yeah, that post, that post, that post, that post, and that post are all battery minus, and it's got literally just this width alone, twice as much width on the circuit board than battery plus does. Plus, battery minus also has all of this, so it's kind of unbalanced a lot. I don't know why they did that. That doesn't make much sense to me. You know, you should make your battery plus and your battery minus buses balanced, but of course, you know, like KO didn't either, so I guess that's no real surprise. So yeah, definitely want to see copper from this post all across here, you know, and go right up to the MOSFETs. Instead, they kind of did this kind of stuff, and, you know, with solder reinforcing, and it's like, come on, guys, do it right. Yeah, so right here and right there is where the three phase posts were, and then by cables, well, not this first one, that one had this little piece of copper that went across there, but from these two, there was a wire, which I have like here, that basically went there and down to this one. That's the wrong one, because it must be that one. Yeah, there we go. So from these studs over to here, and then that brought the phases over to this position right here. So this is a lot like how EBMX did it, just more flimsy, because they didn't use a solid copper bar like what EBMX did. But still sufficient for the job, considering that this is a much lower wattage controller than like EBMX is. But yeah, it's still the same idea, and it was sufficient for the job, obviously. So this power stage brings up something that is of importance, and you can see how these are flopping around. Well, this is very common with an MCPCB, in other words, our metal core printed circuit board, which is what this is. It's got aluminum on the back side, so that's its core. The circuit traces don't adhere super well to the insulating layer, so you can see it through there, and it's white. That's ceramic. And that electrically isolates the circuit traces from the aluminum, because if one was printed right on top of the other, well, it'd be a dead short. You don't want that. Well, the thing is the circuit traces, they do adhere to the ceramic, but they don't adhere super well. So when you have things like this, they tend to pull away. And as you can see, up underneath there, that's just bare ceramic underneath there. Yeah, you can see the brown backside of the copper. Yeah, it's just the nature of the beast. So these were potted, of course, into that Stoneheart potting. So these probably had pretty good support, but, you know, like KO Moto, they don't. They just have, you know, brass standoffs doing the same thing, soldered directly down. But they're a little bit bigger than this, but not a lot. But again, they're just soldered down to a low circle pad, and you would literally twist those things right off. In fact, people have. So, you know, that's something that I've mentioned before. And, well, here's a controller that's got that problem. This one here is loose and floppy, and these two here are completely torn up. Yeah, once you have a situation like this, you're going to be throwing the thing away, because you've ripped up traces. This is not really repairable. Yeah, you're just going to be getting a whole new power stage. So it's not awesome that this is the case. Definitely don't like seeing this kind of thing. If they would have used these same studs, and you've got this like large area right here, if they would have used those same studs, put two of them together, and then stuck the whole thing down to a piece of copper that ran around the whole thing, they would not have torn up like this. They would probably have been stuck down really well, because they would have had a lot of support and enough of circuit trace to the ceramic so they wouldn't pull up. Like what I showed in my EBMX video, I tried to squeeze those two battery plus and battery minus studs together, and I couldn't pull them off the board because they're really stuck down nice and solid. Anyway, yeah, this could be a lot better than this, and you'll have that same problem with the Suron. In fact, you do. You know, yeah, here's that one. These are all torn up. Yeah, the solder broke loose. But yeah, those are broke loose too, and you'll have the same problem with KO controllers, because it's the same design as this. What is the other one? Far Driver, they do it this way too on some of their controllers, and I'm sure they shear off. So yeah, it's not a great way to do it. You really need to support these studs a lot better. This power stage otherwise is pretty good. These are pretty beefy MOSFETs. This has definitely got a lot more chooch in it and a lot more power than like the Suron power stage, which is by far a much weaker power stage, just in MOSFETs alone. These MOSFETs have much lower resistance, about double the amperage, about double the heat handling capability. So yeah, there's a lot of things here that are kind of good. Like the Suron, there is a single temp sensor right here, and that's it. It's not very good for high frequency filtering. So there are 4 little itty bitty ceramic caps here. There were 4 right here, but they pulled up with the potting. And then over here, there's 1 of 4 left. The other 3 pulled up with the potting, but yeah, these little dinky caps are insufficient for the job. That's just how that is. There should have been a lot more ceramic caps, a lot bigger ones than this. So yeah, it's inadequate in that regard. Probably this is a fairly noisy power stage just because it doesn't have any high frequency filtering, hardly worth having. But yeah, that's pretty much it. Next video I do on this, I will start looking at part numbers and get the macro lens out, and we'll look in real close and look at some of the parts and things. Yeah, it's got some good aspects of it and some not so good aspects of it.